Okay, if you step back and observe the most successful learning systems we know, like think about a bat's sonar or how a child learns language, you realize pretty quickly these amazing mechanisms weren't, designed in a lab. They were discovered by evolution over millions, literally millions of years of trial and error.
Right. Refined constantly to be incredibly robust, incredibly powerful ways to learn and adapt.
Exactly. Now, contrast that with artificial agents with AI. For basically its entire history, AI has been limited by the learning rules we gave it, rules we designed manually.
Yeah, relying on human ingenuity, our intuition,
Hmm.
which is often slow, sometimes flawed. So the big question, the really exciting one driving this deep dive is, what happens when the machines stop waiting for us? What if they start discovering the rules of learning themselves?
We're looking at a specific breakthrough source today detailing how machines actually did this. They discovered a top-tier reinforcement learning, or RL algorithm, and get this, it outperformed the best ones humans had painstakingly built over decades. It's huge. This isn't just AI doing tasks anymore. It's AI designing its own intelligence. Okay, let's unpack this. How AI managed to become its own algorithm architect.
Well, you said it. This has been like the holy grail for AI research for a long, long time.
Yeah.
The challenge, honestly, it's hard to overstate how difficult this has been.
Right.
For decades, people have been trying to get machines to autonomously discover really powerful general RL algorithms.
So the core finding here is it's possible.
It's possible. That's the immediate takeaway. The machines did discover an RL rule that's demonstrably better, significantly better than the ones humans designed. But the real juice is in how they did it and how well it actually performed. That's what we need to dig into.
Okay, let's start there with the human limitations side. Usually when we talk about RL agents, their ability is kind of capped by the learning rule they use, right? Like Q-learning or policy gradients.
Exactly. Those are the handcrafted instructions. An engineer literally writes the code telling the agent how to adjust itself based on rewards or penalties from its environment.
And trying to make those rules better manually is just incredibly hard. You tweak something here, test it, tweak it again. Progress is slow, incremental.
And limited by our own biases, our own ways of thinking. We've needed a better way, like you said, something closer to how nature finds these powerful general solutions.
So the better way, according to the source, is this thing called meta-learning.
That's the key. Meta-learning. It's a shift in perspective. Instead of training an agent, say, Agent A, just to play game X really well,
Okay.
they trained a kind of master system, the meta-learner, its only job, to watch a whole bunch of other agents learning and figure out the absolute best way for them to update their internal strategies, their policies.
Okay, so it's learning about learning.
Precisely. The source says it learned from the cumulative experiences of a population of agents across a large number of complex environments. Think.
Yeah.
Like a massive digital ecosystem. Thousands of agents trying millions of strategies in hundreds of different simulated worlds all at once.
Wow.
And the meta-learner is just observing this whole collective mess, this huge amount of experience, and extracting the optimal way to adjust, the best learning rule.
So what's fascinating is, it didn't learn to do a task. It learned how to learn better, faster, across lots of tasks. It optimized the learning mechanism itself.
That makes a lot of sense. Optimizing the optimizer, like a super fast digital version of natural selection, finding the best thinking strategy. But okay, let's get specific. What was the rule it found? Like, how does this machine-discovered thing actually work compared to what we used before?
Right, it gets technical, but the core idea is it dictates how the agent updates its policy, what it does next, and its predictions, what it thinks will happen. Human rules often use, relatively simple, fixed methods, standard stuff like gradient descent with fixed parameters.
The machine-discovered rule. It's adaptive. It found a much more sophisticated, context-aware way to update. It learned how to dynamically adjust things like the learning rate, how much to weigh past experiences, how to calculate errors, all simultaneously, in a way that just maximizes future success.
So it's not just tweaking numbers, it's changing the structure of the update itself based on the situation.
Exactly. It's flexible, dynamic, optimized way beyond what we can easily write down in standard math notation.
Okay, that's clearer. It's a fundamentally different kind of update mechanism. So, the big test, performance. How did this machine rule actually do against our best human-designed ones? They went straight for a major benchmark, the Atari suite, which is important because it's not one game. It's like almost 60 different games needing all sorts of skills.
Yeah, that's a classic.
That's a classic test bed. Needs a really general algorithm.
And the result was, well, it's pretty definitive. The source says the discovered rule surpassed all existing rules on that benchmark.
All existing rules.
All of them. Not just edged them out, but showed a clear superiority over decades of human effort on Q-learning, policy gradients, all the state-of-the-art stuff. It really challenges that assumption that humans have to be the ones designing the core intelligence.
Yeah, that's a massive claim. But hang on, let's bring in a practical point here. This whole meta-learning process, the population of agents, the large number of environments, that sounds computationally insane. Like, it must take unbelievable amounts of processing power, right?
That's a really fair and important point. Yes. The discovery phase, the meta-learning itself, absolutely massive resources needed. You're essentially setting up this huge digital evolutionary sandbox.
So does this mean only, like, giant tech labs with supercomputers can find these new algorithms? Does it make AI development less accessible?
Well, yes and no. The discovery is super expensive, resource intensive. But the actual discovered rule, the piece of code that tells agents how to update, that can potentially be used by any agent afterwards.
Ah, okay. So the upfront cost is huge, but the resulting algorithm could be shared and used more widely.
That's the idea. Once discovered and shared, this highly efficient general rule could actually boost performance for lots of people, theoretically democratizing the application, even if the discovery is concentrated. Okay, that distinction helps. But let's get to maybe the most crucial test. Generalization. Doing well in Atari. We're kind of trained, that's one thing. But real intelligence needs to handle stuff it's never seen before. Did it work outside that training environment? It did. And this is where it gets really compelling. They specifically tested it on challenging benchmarks that it had not seen during discovery.
So completely new problem.
Completely new types of complex decision-making tasks, not just variations of Atari. And yes, the performance held up. It still outperformed the state-of-the-art human-designed algorithms on these totally unseen benchmarks. That's the proof. It shows the meta-learner didn't just find some clever trick for Atari. It found a genuinely deep, generalizable principle of learning, a robust strategy for tackling novelty. Okay, so let's recap the key results. The machine used meta-learning to discover a fundamental learning rule. It beat all the human-designed rules on the standard Atari tests. And crucially, it generalized, performing well on totally new, unseen problems.
Right.
Which brings us to the big implication. The source puts it quite plainly. The RL algorithms required for advanced artificial intelligence may soon be automatically discovered from the experiences of agents rather than manually designed.
That sounds like a fundamental shift.
It really is. It suggests we might need to change how we even think about building advanced AI. Maybe our main job isn't engineering the algorithms piece by piece anymore.
And engineering the process that finds them.
It's exactly. We become less the direct crafters of the intelligence and more the architects of the environment, the digital evolutionary system, where optimal intelligence can emerge and be discovered. If you connect this to the bigger picture, it suggests the fastest path to really powerful general AI might not be through slow human discovery, but through massively scaled machine experience, finding strategies we wouldn't even think of.
That really does change the game. If machines can successfully meta-learn rules that beat our best efforts, well, that could seriously accelerate progress towards more advanced general AI. So what does this all mean? I guess it means the machines are genuinely learning, how to think better on their own. It's like a digital evolutionary leap. Maybe the best way forward for tackling really complex open problems is to let the machines figure out how to solve them.
It loops right back to your starting point about evolution, doesn't it? Nature found complex learning rules through massive experience over immense timescales. We've now kind of replicated that process digitally, but massively sped up.
Yeah.
Once you have a system that can autonomously generate powerful new ways of learning, who knows what the limit is?
No.
The ceiling might be much, much higher than we imagined. Definitely something to chew on.
It absolutely is. And we really want to know what stands out to YU about this deep dive. What are your takeaways? Share your thoughts or any questions you have down in the comments section below. If you enjoyed this exploration, cutting through the noise to get to the core ideas, please do encourage us. You can like this video, share it, and subscribe to my YouTube channel, Everyday AI Podcast. That way you'll stay updated on all the latest AI insights and trends we cover. Oh, and don't forget to hit that notification bell so you know exactly when new deep dives like this one are released. Thanks for joining us, and we'll catch you next time.